Define h from R to R by the rule h of x equals x squared for each real number x. Part I. Is h 1 to 1? Prove or give a counterexample. Now, we actually talked about this explicit example at the end of the last video and in a previous video before that. But let's draw this function. This is from R to R. What that really means is that our domain is the x-axis, which is just the real number line. The codomain is also the real number line. So we're going to draw both axes entirely because they're defined here. Now, this is h of x equals x squared, and you're probably all familiar with this parabola shape. So let's talk about the first part. Is h 1 to 1? Now, if you've taken pre-calculus before, you might have learned what's called the horizontal line test, which is a really good test, especially if you graph these things, to see if this function is 1 to 1. In this case, though, there are plenty of examples where you have two different inputs, let's say -3 and +3, where if you square these numbers, you end up getting 9 either way. And so the output 9 is repeated. And this is true for almost every output here, except 0, which is at the bottom here. So is it 1 to 1? No. But just to really clear up why, we need to provide an explicit counterexample. This is a good counterexample, but to write it out explicitly, we can just say h of -3 equals 9, which equals h of 3. And this is the explicit counterexample that we need to write in function notation. So that's the first part here. The second part is h onto? Prove or give a counterexample. Meaning that is every element in this y-axis here an output of this function? Well, the range of this function is not the entire y-axis. The range of this function only goes from 0 to infinity. So no, the function's not onto, but we need to be able to provide a counterexample, meaning that we need some element in the codomain, some element on this y-axis that's not an output. And I think a really good one is -1. h of x equals -1 has no solution. And the reason is simple. It's because if we set x squared equals to -1, then there's no solution to this. This would be x equals plus or minus the square root of -1, but you can't take the square root of -1, at least in this class, which means that there are no x values that are in the real numbers specifically that gives an output of -1, even though -1 is in our codomain. So there are elements in our codomain that are not outputs of the function, and so it's not onto. So this function is neither 1 to 1 nor onto. But now let's talk about this new function, k, from the non-negative real numbers to the non-negative real numbers. Specifically, if you've taken calculus or pre-calculus, this is the interval from 0 to infinity to the interval from 0 to infinity. So that's what they mean by r non-neg to r non-neg. That's the interval from 0 to infinity to the interval from 0 to infinity. Now let's draw what this would look like. This is not just like any old x and y axis that we're so used to drawing. In this case, our domain is the non-negative real numbers, which means I'm going to draw a horizontal line that starts at 0 and goes to the right. It doesn't go to the left at all from 0 because there are no numbers here in the domain that are less than 0. And so we're not even going to draw that part of the x-axis. Now, the codomain is also the same thing, so we're only going to draw that part of the vertical axis. And now we can draw our function k of x equals x squared, which is still a parabola shape, but it's only this half of the parabola. It's the right half of the parabola. There's no more left half. The question is k onto? Meaning that is every element in our codomain, which is just this portion of the y-axis, is every element here an element, an output of the function? Well, the answer is yes. You pick any sort of height in this function, we can find specifically an input that maps to that output. But let's prove that. To prove this, we're going to let r be an element in the codomain. This is just a fancy way of saying that r is greater than or equal to 0. Now we need to show that there's a number that we can plug in from the domain that gives specifically the output r. So what can we plug into this function that's in the domain that gives us the output r? We have to think about the inverse function, which the inverse function to squaring is the square root function. And it turns out that if we plug in the square root of r, we end up getting the square root of r squared, which the square root and the square cancel here, and we end up getting just r. The question is the square root of r in the domain? Well, r is a non-negative integer, meaning r is greater than or equal to 0. But since neither side here is negative, then we can actually take the square root of both sides to get the square root of r is greater than or equal to the square root of 0, which is equal to 0. So that means that the square root of r is also greater than or equal to 0, which means that the square root of r is an element of the domain. And that's super important, because if the square root of r is an element of the domain, then that means we can plug it into the function and we end up getting the exact output that we need to show that this function is onto. So from here, we can conclude that k is onto. Thanks everyone, and I'll see you in the next video.